In pursuit of transferring technical knowledge and just to gear up the new engineering entrant, myself Pranav is here to deliver today's presentation, Power Transformer Part 69. As the topic is of the continuation, so for your convenience, the link of the previous one is given under the description box. Now let's start with the designing conditions as imposed for the insulation part, Central Electricity Authority has put up his recommendation that the mineral oil immersed power transformer would have been so designed that it must have to capable of being overloaded in accordance with IEC 60076-7. In IEC 60076-7, where it describes the actual effect on the life of transformers as these assets while are being operated under the various ambient temperatures and load conditions. Short-time emergency loading that may cause the conductor hotspot to reach a level likely to result in a temporary reduction in dielectric strength at that part of the solid insulation as provided. However, duration of such overloading must be shorter than the thermal time constant of the whole transformer and depends on the prevailing temperature just at the moment of load shoots up. But it is important to note that the oil temperature is not a reliable indication for the winding temperature, since the thermal time constant of oil is 2 to 4 hours, while the thermal time constant of winding is 2 to 6 minutes. So, it is much more difficult to determine the permissible duration and the respective levels of the acceptable overloadings, as because there may have the danger of the winding temperature exceeding the critical temperature of 105 degrees centigrade or 110 degrees centigrade without being visible for the oil temperature. Therefore, the determination of the permissible duration and the respective levels of the acceptable overloadings that should have to be carried out in consideration with the underneath factors. 1. Transformer's previous continuous loading pattern. Number 2. The corresponding windings and oil temperatures just at the very moment of overloading to begin with. These 2 points. 1. The transformer's previous continuous loading pattern. Number 2. The corresponding windings and oil temperatures just at the very moment of overloading to begin with. That is just at the point of starting of overloading the transformer. Winding insulation as it is being very much sensitive to rise of temperature, so the winding hotspot temperature monitoring is rather to be an essential factor for the determination of a safe and realistic load optimization characteristics. Online winding hotspot temperature monitoring can also have to ensure the prescribed operating limits of a transformer without compromising its life expectancy or reliability. Though the transformers are being extremely energy efficient, But the dissipated heat as generated would always be a crucial limiting factor to adjudge the loading pattern of power transformers. The insulating medium as provided should have to be capable of dealing with large electrical stresses, strong electromagnetic forces, and high temperatures. These three: large electric stresses, strong electromechanical forces, and high temperatures. It is obvious that the life of a power transformer mainly depends on the condition of its paper oil insulation system. Oil impregnated paper, as that has to cover the major part of electrical insulation system, so quality and condition of the paper would always be the most critical factor in manufacturing paper oil insulation system. Main winding of power transformers for rated current of 400 ampere or more should have to be made by the epoxy bonded continuously transposed conductor. Regarding transposed conductor CTC, we have already discussed in previous uh, previous article. By using continuously transposed conductor CTC as for the main winding, that would lead to minimize eddy currents and to equalize the distribution of currents and temperature all along the winding. Again, I repeat, by using continuously transposed conductor, that is CTC, as for the main winding, that would lead to minimize eddy currents and to equalize the distribution of currents and temperature all along the windings. To achieve higher mechanical strength, it is recommended that the conductor insulation should have to do with high density kraft paper, perfectly or preferably more than 750 kg per meter cube. According to ISO 534 2011, the density of kraft paper is preferably in between 630 to 870 kg per meter cube. Again, I repeat, to achieve higher mechanical strength, it is recommended that the conductor insulation should have to do with high density kraft paper, preferably more than 750 kg per meter cube. According to ISO 534 2011, the density of kraft paper is preferably 630 to 870 kg per meter cube. Now, influence of temperature and water on the life of the oil immersed power transformers. Temperature rise is one of the most significant factor, as that would have to affect directly on the safe and stable operational features of power transformers. Any instance of thermal problem that would thus to influence a rise of operating temperature of the corresponding transformer and its associated components. High operating temperature must have to enhance the thermal stress in power transformers, causing to accelerate chemical reactions such as pyrolysis, oxidation, hydrolysis to occur in both transformer oil and cellulosic paper insulations. It is important to note that the behavior of the moisture content as present in the oil and cellulosic paper would have been different at different level of temperature. Basically, when the transformer is underloaded or at inoperative condition, then the cellulosic paper would absorb moisture from the insulating fluid, that is from the oil. But with increase of temperature, the cellulosic paper would start to release its moisture content and that to precipitate into the insulating fluid. So, higher be the operating temperature, that would lead to larger content of moisture in the insulating oil. Moisture in oil or cellulose, while combined with oxygen and heat, that would propagate a chemical reaction to just have to produce more water. Again, I repeat, moisture in oil or cellulose, while combined with oxygen and heat, that would propagate a chemical reaction to just have to produce more water. The water content in the paper actually has to build up over the entire lifespan of the transformer. And that would lead to act as a byproduct of the breakdown of the cellulose polymer chains. So far, oil immersed power transformer is concerned, there would have some crucial as well as intricate relationship in between the operating temperature and the performance of dielectric fluid, which served as both coolant and an insulator. While a dielectric fluid is functioning under prolonged exposure to elevated temperatures, then thermal degradation would have been the primary concern. Thermal degradation process once started, that leads to a process of chemical breakdown within the oil composition, causing some formation of harmful byproducts such as acids, sludge, and gases. Moreover, excessive heat and moisture would have to facilitate the breakdown of cellulose insulation, leading to insulation failure. Moreover, excessive heat and moisture that would have to facilitate the breakdown of cellulose insulation, leading to solid insulation failure. During contingency conditions, transformers might have been operated with overloaded condition. During contingency conditions, transformer might have been operated with overloaded condition. But overloading criteria that may have to allow up to a certain limit till the transformer's insulation has to maintain its technical integrity with the prescribed design parameter. For power transformers, as the accelerated aging is one of the main consequences of overloading, so to counteract any abnormal overloading situation, it requires to implement properly executed planning and controlling system. It is much essential to design and implement the heat transfer characteristics between windings and oil in order to predict the hotspot temperature in the transformer as a function of the load, while considering the cooling characteristics. By comprehending the abnormal loading sequence with the actual thermal effect that oil and winding temperatures have on the life of insulation, it is rather to be recommended to follow the guideline of IEEE for loading of oil immersed power transformers C57.91 2011. Again, I repeat, by comprehending the abnormal loading sequence with the actual thermal effects that oil and winding temperatures have on the life of insulation, it is rather to be recommended to follow the guideline of IEEE for loading of oil immersed power transformers C57.91 on 2011. Practically, In oil immersed power transformer, there are two main drawbacks of its insulation system, which basically comprised of insulation oil and insulation paper. One, thermal limitations, and two, great susceptibility to water ingress. These two, thermal limitations and great susceptibility to water ingress. Through several experimental studies, confirmation has been made that moisture is one of the major source of insulation failure in high voltage power transformers. If moisture is not allowed to enter into transformer, then the permittivity of oil impregnated paper and the oil itself both are practically be the same. Mineral oil that has an excellent insulating property and also acts to disperse the heat from the transformer's core and windings. In this way, liquid dielectric would have to protect cellulose paper also. Once the oil becomes contaminated with moisture, particles or other impurities, then its insulating properties would have to deteriorate. It is important to note that higher the values of oil breakdown voltage, that is more than 71 kV, that indicates the lower the presence of contaminants. The decrease of breakdown voltage would be the clear indication of aging transformer oil. Cellulose paper and pressboard both would have to act as dielectric by storing electrical charge when the transformer is energized, and that would contribute to better thermal health of the transformer by creating cooling ducts for the oil. However, a fact related to presence of water in transformers is one of the major life-threatening substance, as because that would lead to some detrimental effects of transformer insulation system both in cellulosic paper and oil. Now see, a main factors that can cause a transformer to fail its insulation unexpectedly. One, temperature, humidity or water content, acidity, oil contamination, oil viscosity, oil breakdown voltage, and degree of polymerization in cellulose paper. B, water content in the oil and paper insulation system would be the most significant concern among the factors, as it can lead to one, reduction of dielectric strength of the liquid and solid insulation, acceleration of cellulose's aging process, evolution of gas bubbles at high temperatures. Points to be noted. It is important to note that solid insulations inside the transformer, such as paper and pressboard, would have more affinity for moisture than oil does, rather. Most important. See, in transformer, moisture may have to exist in several forms. One, water vapor in gas space of the transformer. That is, gas space means water, the transformer insulation, the solid insulation. Water dissolved in the oil, free water suspended as droplets in the oil, emulsified water contained in the decay products as of oil oxidation, water absorbed into or adsorbed onto the solid insulation. Absorption involves the mass transfer of particles into another material, while adsorption means adhesion of particles onto the surface of the substance. And number 6, free water that has settled to the bottom of the transformer. These 6 points to be noted. Water vapor in gas phase of transformer or transformer insulation, solid insulation part, water dissolved in the oil. Number 3, free water suspended as droplets in the oil. Number 4, emulsified water contained in the decay products as of oil oxidation. Water absorbed into or adsorbed onto the solid insulation. Absorption involves the mass transfer of particles into another material, while adsorption means adhesion of particles onto the surface of a substance rather. Free water that has settled to the bottom of the transformer. Number D. In transformer, moisture may have to enter in several ways. 1. Through leakages as due to damaged gaskets for bushings, covers, pressure relief devices, leads, and gauges. Number 2. Through breathers where the desiccants would have been exhausted. Number 3. Wet nitrogen, if used for gas blankets, would have to contribute moisture. Water is chemically bound to the cellulose molecules in the paper insulation, which has to release as due to its aging or high temperature. Moisture that is chemically bound to the hydrocarbon molecules in the oil, which has to release during the process of oil oxidation as well as due to aging. Number 6, the core, coil assembly and all solid insulation may not be dried up to an acceptable level during manufacturing time. Factories, insulation manufacturing or after maintenance. Factories' insulation drying process should have to ensure that the residual moisture content of bulk solid insulation remains below 0.5% or otherwise there would have some residual moisture. Again, I repeat, factories' insulation drying process should have to ensure that the residual moisture content of bulk solid insulation should have to remain below 0.5% or otherwise there would have some possibility to have residual moisture. Now, effect of water content in transformer. The composite insulation system, oil and paper of transformer is always being exposed in temperature, electric field strength and mechanical stresses. The aging process of the insulation systems based on impregnated cellulose materials would have to depend on the combination of these exposures. The aging process would have been escalated if there may have the presence of moisture in the cellulose, especially at elevated temperatures. Therefore, water content in the insulation system is one of the most important aspects affecting the life of the insulation. The presence of water in transformer oil paper insulation system that can lead to dielectric failure, acceleration of cellulose's aging process, and emission of gas bubbles at high temperatures. It is important to note that the highly hygroscopic nature of cellulose insulation can also be detrimental to cellulose fiber insulation's performance. Excessive moisture retention from 4% to 8% by weight would have been observed in cellulose insulation while to undergo its drying process. The conventional method of drying process of cellulose insulation that involves to utilize the heating and vacuum techniques within a long scale vacuum dryer, within a large scale vacuum dryer, where the temperature can be raised to approximately 85 degrees centigrade to 130 degrees centigrade as per requirement or as per class of insulation. Prior to applying insulating oil, it is essential to ensure thorough drying of the cellulose solid insulation inside the transformer so as to keep the water content of solid insulation just under 0.5% by weight at the end of the factory acceptance tests. Mineral insulating oil, as originally supplied, would also have some dissolved water content whose limit is of the order 30 to 35 ppm parts per million of water, would generally be referenced as acceptable standards. Again, I repeat, mineral insulating oil as originally supplied would also have some dissolved water content whose limit is of the order 30 to 35 parts per million or ppm of water, would generally be referenced as acceptable standards. Before, before filling in the transformer, it would be the best engineering practice that the mineral oil must have to go through a rigorous dehydration and filtration processes so as to dry out the oil up to a limit of less than equal to 5 ppm of water. Concentration of water molecules in oil that would have to vary with temperature, and if that concentration has gone to 30 ppm at 42 degrees centigrade, then the transformer would have been referred as fairly wet. Most important. Again, I repeat, concentration of water molecules in oil that would have to vary with temperature, and if that concentration has gone to 30 ppm at 42 degrees centigrade, then the transformer would have been referred as fairly wet. In IEC 60296, where it provides the standard specifications for both the unused and recycled mineral insulating oils. However, aligning with international standards IEC 60296 2012, the Bureau of Indian Standards has introduced IS 335 2018 for providing an improved version of quality control and compatibility of using mineral or synthetic oil in Indian electrical infrastructure. Again, I repeat, however, aligning with international standards IEC 60296 2012, the Bureau of Indian Standards has introduced IS 335 2018 for providing an improved version of quality control and compatibility of using mineral or synthetic oil in Indian electrical infrastructure. In IS 335 2018, where provides specifications of quality insulating oil of having high dielectric strength, high thermal stability, low moisture content, high oxidation stability, better compatibility with materials, biodegradability, and environmental safety. In the specified standard IEEE C 57.106 2015, where it configures a systematic guidance for acceptance test and typical maintenance of insulating mineral oil in electrical equipment. Underneath guidance that has been provided by the standard IEEE C57-106 2015 so as to maintain the optimum characteristics of the new unused mineral oils. A. Significance to perform the prescribed analytical tests for the evolution of new unused mineral insulating oil before and after filling into the equipment. Number 2. Analytical tests to evaluate in-service mineral insulating oil. C. Procedural aspects on health and environmental care as for the operator to provide technical assistance in maintaining the mineral oil in serviceable conditions. Number D. Methods of handling and storage of mineral insulating oil. Let's stop here, further to be continued at later stage. Thank you. Thank you for listening the video. Kindly do like, share and subscribe. Your subscriptions would encourage to post more videos. Also share your comments or feedbacks inside the dedicated comment section. If you have any suggestions or specific topic you want, then let me know in the comment section, please. Thank you. Thank you for patient hearing.